Okay, first I need you to grab this set of notes. Those that's using the textbook, we are still on polygons. I really cannot wait. We are running very short of time, so try and stay focused. If this goes too fast for you, the video is in the Google Classroom. You can come back to it and catch up with it when you go home, okay? So let me quickly go on. So we've done our quadrilaterals, which is the four-sided figures. Then we went on to our construction. So let me just quickly go through. We did constructions. Then you did what's called arcs. Okay, we did a bit of construction, no problem. Not doing constructions anymore. You want to play, you can play with it yourself. So we're gonna go on. Okay, we're gonna go on. Move. I am at slide number 32. These are called polygons. Polygons are just shapes that's formed by a number of sides. The sides must be straight lines. If not, we can't call them polygons. Okay, if not, it become one big circle. So we know the triangle, we know the quadrilateral. I will need you to know the remaining of these names. A five-sided figure is called a pentagon. Okay, this color is not very good. Let me just darken it a little. Okay, the five-sided is called a pentagon. Okay, same as the pentagon that you have in US. Six-sided is a hexagon. This one you really have to know, it's not a choice. A heptagon is 8 sides. The word G-O-N is always at the end. So hepta at the front means 7. Octagon, octopus, octagon. Nonagon, you remember it because it has two, it's the, when you spell your 9, right, it's N-I-N-E. So nonagon. Okay, and then 10 sides, decagon. Decimal 10 sides, so dectagon. Okay, I don't know why it's red in color, but please allow me to change. Okay, so the prefix, that means the words that's in front, this penta, hexa, quad, octa, nano, deca, and hepta, these are the prefix. They tell you the number of sides. I don't need you to remember anything more than that. After your decagon, you can stop. You can call it n-gon, you can call it 11-gon, you can call it a 12-gon, but I need you to know until a decagon. Okay, so decagon polygons, there's only two major formulas. The angles that's inside a polygon, doesn't matter what shape you anyhow draw also can. Okay, those inside the figure, we call them interior angles. Can see, right, the interior angles are actually quite big. Okay, so the interior angles have this formula. Sum of interior angles is n minus 2 times 180 degrees. I know the way I write this is a little different from the way the book write this. Why is it like that? I actually can break it down for you. 180 is triangle, right? So basically every polygon, if I cut it, I can cut it into triangles, but you must cut from corner to corner. For example, this is 5 sides. The first 3 sides will form one triangle. This is the first triangle. It will take 3 sides. Okay, then 2 triangles, 3 triangles. So 5 minus 2 times 180. Can see the 3 triangles? So the minus 2, right, is actually to account for the first and the last triangle, which requires an additional side. Okay, that's why there is a n minus 2. So 180 because of the triangles. Okay, let's go on. I know I am fast, so if I'm going too fast for you, come back to this later. So it works for all polygons. That means it must be closed. So now look at this. First, I need you to decide how many sides. Must count lah. Okay, let me go and grab my calculator. Okay, so all the angles inside the polygon will add up to n minus 2 times 180. So let's add them all first. 107, 121, 3a. N is 5. 1, 2, 3, 4, 5. This is a pentagon. So 5 minus 2 times 180 degrees. Okay, the calculator, do some adding first. This is 228. I write until I'm very confused. 3 times 180, 540. So now the rest of this is just like your algebra. So I minus 228 on both sides. Align them based on the equal sign. So my A is 104. Okay, my A is 104. You can choose not to write all the degree sign if you want, because it's A degrees. So you work with the value of A. Let's look at the second one example. I underline first. You can pause this later or you can come back to this later, okay? So first thing you do is, I need you to look at the number of sides. 1, 2, 3, 4, 5, 6. This is a hexagon. So let's add up all my angles. I need you to be very synchronized. You need to know what you are doing. 7b is hexa. 6 minus 2 times 180 degrees. Okay. Interior angles, the angles that's inside the polygon. So this is a 468. The other side, 4 times 180, 720 degrees. Okay, I minus 468 on both sides. Now I divide by 7. My B is 36. Okay, B degrees is 36, so B is 36. Okay, at the same time, if you want to remove, you remove. Okay? Make sure you don't have one with degree sign, the other one don't have. They must be consistent. Interior angles. Okay, interior, inside the polygon. Go on. So now you see this very interesting word called regular. Regular figures, right? Regular figures, regular dectagon, regular whatever not. Regular means all angles equal. Whether it's interior or exterior, all sides equal. Okay, so let's continue. Part 1. Sum of interior angles. Please give me my simple statement. A decagon has 10 sides, so 10 minus 2 times 180 degrees. So if it is a regular decagon, that means all the angles are the same. 10 sides, you have 10 angles. You see, let's go back and check. 5 sides, 5 angles. Can you see? 5 sides, 5 angles. 6 sides, 6 angles. So if I have 10 sides, then obviously I have 10 angles. So interior angle Okay? Gonna move on a little bit more. So, practice now 13, part 1. Find the sum of interior angles. We want the sum, not 1, we want the sum. 24 sides, that means n is 24. So let's start there. Part 1. Sum of interior angles. I want some statements. N is 24, so 24 minus 2 times 180 degrees. You don't have a choice. You have to remember this formula. Press calculators with me. The more number of sides, right, then you realize the interior angle gets bigger and bigger and bigger. Eventually, it becomes something like a circle. Okay? So after I find the sum of interior angles, now I can find one interior angle. 24 sides, 24 interior angles. Okay, number 1 is done. Let's take a look at number 2. Oh, this one favorite. Star it, please. They always set this for the exams. So let's take a look at this. Now, I need you to find x. So what you can do is, I can find this one, let me call it A. I can find this one, let me call it B. And then I take 360 minus. Let's look at A first. 1, 2, 3, 4, 5. Pentagon. So A is pentagon. All the angles add up. I divide by 5 sides because I only want one of them. Okay. B is a hexagon. So sum of all the interior angles, I divide by 6 because a hexagon has 6 angles. So 120. Now I can find x. 360 minus 108 minus 120. Angles at a point. Okay, the angles add up to 360 degrees. I hope you can hear me. I know I'm getting softer and softer. 132. Okay, very popular question. Please take note of it. Let's do a bit. Unfortunately, questions like number 2 is not very obvious. Not very obvious. It's just not very common to be said. So let's take a look at number 3. This is an octagon. 8 sides. I need the sum of interior angles. I need statements, please. Okay, press your calculators. Part A done. It's actually a pretty simple chapter. There are only 2 formulas. Each interior angle. Octagon means it has 8 angles. The number of sides and the angles must be the same. Okay? Let's do B, a quick one. I have a 18-sided polygon, so 18 gone. So sum of interior angles. Okay, let's continue. Part 2, one interior angle. 18 sides means 18 angles. 160. Okay, usually questions look like that. I finished teaching everything first. So, after we know what is the interior angle, the next thing I need to teach you is called the exterior angle. Now, the interior angle plus the exterior angle must always give you 180 degrees. They are supposed to be angles on a straight line. Okay? Not the big fat one, it's just extend the line and 180 degrees. Why? If you actually draw this out and you cut them, right, the exterior angles will form one circle. Really, the exterior angles will form one circle nicely. So, sum of exterior angles, no matter how big, how small the polygon, will give you 360 degrees. Okay? Draw right properly. This one is the easier one, really easy. There are some apps that you can play with. I'll show you when I get back. Show you how we put this together. Here, sum of exterior angles, 360. Always 360. This is a regular polygon. That means all sides equal, all angles are equal. Each exterior angle is 24. So the number of interior, exterior equal sides equal number of interior angles and equal exterior angles. Every single thing is equal. Let's go for them first. Exterior angle of a polygon. The exterior angle is 24. Find the number of sides. So each angle is 24 degrees. I multiply it by the number of sides, which is n. I don't use n, I use number. Must give you 360. So number of sides (15). We are on exterior angle, so I should keep to the exterior angles. They give me interior angle, so I find exterior angle first. Exterior angle equals to 180 minus 162. (18 degrees). So number of sides equals to 360 divided by 18. 20 sides. Okay, it's pretty simple. I need you to try a little bit. Pause the video here. Try your 14. Okay, pause it here. Try your 14. Sorry. We are finding the number of sides. Finding exterior angle. First, I'm given exterior angle. Second, I'm given the interior angle. Okay? Try. The number of sides is equals to 360, which is the sum, divided by each interior angle. This is a 9, so it's a nonagon. Okay? Let's continue. If each interior angle is 165, that means I can find the exterior angle. Very small. Exterior angle is only 2 degrees. So number of sides, 360 divided by 2, Wow, this is 18 sides. Serious, 180. Okay, let's continue and finish up. This is a dectagon. That means it has 10 sides. Okay, so 10 sides, 10 angles. Number 2, 10 sides, 10 exterior angles. So each exterior angle will be 360 divided by 10, which is 36 degrees. So interior angle will be 180 minus 36, 144 degrees. Okay, technically it's angles on a straight line. What does it look like? It looks something like this. Okay, so this one is the interior. When you extend the line, when you extend the sides, right, then you will have the exterior angle. Okay, exterior angles usually pretty small. Okay, this one needs to visualize. I am going to continue a little bit more. Those that cannot digest, go home. Please look at the video one more time, okay? Let's take a look at this one again. I have a regular pentagon produced to meet F. Let's draw a pentagon first. Help you visualize. The iPad very good. They always draw you a very nice pentagon. They always give you a regular pentagon. I don't know why. Okay. AB extend. Produce means extend. AB extend. DC extend will meet at the point F. Let me shift this down a little bit. Find the value of BC, this one down here. Okay, so first you must notice that interior, exterior, both these angles are exterior angles. Okay, and they are equal. So first thing we want to do is find exterior angle of pentagon. They add up to 360 divided by 5, 72 degrees. Now focus on the triangle BFC. Okay, so angle BFC is 180 minus 72 minus 72 degrees. I don't even need to tell me it's isosceles because they are all exterior angles. They must be the same. I'm sorry. 36 degrees. Okay. You try this one first. You try 15 first. Cannot visualize, draw, sketch. Did they make a, or they made me a pentagon? 1, 2, 3, 4, 5, 6. They made me a pentagon again. Can they draw hexagons? 2, 3, 4, 5. Oh, I think it's because I lousy. Okay, it doesn't work. They always give me a pentagon. So I'm just going to draw a hexagon. Okay? I have a A, B, C, D, E, F. So I lengthen my AB. I lengthen my DC. And they cut at G. I'm looking for this angle. Same thing. you'll find that this triangle consists of two exterior angles. Okay, so let's find exterior angle first. My handwriting is atrocious. So if these two exterior angles are 60 each, then obviously I am looking at a equilateral triangle. Okay. Okay, do a little bit more, then I stop, okay? Let me do example 16, and then you do try it 16. You do practice now 16. Two of the exterior angles are 26 and 34. The remaining exterior angles are equals to 20. What is the value of n? I am talking about exterior angles. So they're going to add up to 360. Let's form that equation. One angle, two angle, the remaining 20 degrees each, and minus 2 must give me 360. Form my equation first. So 20 degrees and minus 2 equals to 300. My n minus 2 equals to a 15. So n equals to 17. Okay, find the value of n. Hence, find the sum of interior angles. Okay, let's throw formula. Sum of interior angles. 17 minus 2 times 180. It is all about formulas, so I kind of just need you to remember the formulas. Press. Okay, so I want you to clear practice now 16. Oh, a little bit more. And practice now 17. Try it first, Let me do example 15 for you. Okay, first let's read. It's a regular polygon. So I put in all my equal sides. Can you see isosceles triangle? Yes, Good. So first I need the exterior angle. I don't know how many sides, but I do know that the exterior angle is down here. I drop it. So if I find the interior angle, then I take 180 minus interior angle, I will get exterior angle. Or if you know the shortcut, it's called exterior angle of triangle. I do it the long way. Okay, angle BCD minus 12 angle sum of triangle. You want to use base angles of isosceles triangle also can, So my angle, let's call this X, because I extended it. XCD is 24. That's the exterior angle. Now that I know one exterior angle, this is the exterior angle. Let's write my statement outside. Now that I know one exterior angle, I can find the number of sides. N, which is the number of sides, will be 360 divided by one exterior angle, 336, Oh, sorry, I pressed wrongly. Dreaming. 15 sides. Next, I want to find angle A, B, D. Can see this is actually an interior angle. Then after that, I minus away this 12. Okay, so I'm going to find my interior angle first. Interior angle is 156. We found it in part 1. So now I take away 12. Angle ABD 156. I take away 12 degrees because that one is an isosceles triangle. Okay, so I take away 12. 144. Okay, so I'm asking you to try 2 questions. One is 16 and one is practice now 17. These 2 are very important questions. They are highly likely to appear for your exams, so make sure you try them. Okay, those that's faster, you can start with your workbook already. Okay, I'm gonna finish going through this one. Practice now 16. Try it first before you look at my answer. So they are exterior angles. Each exterior angle is 58. 2 of them are given. So I'm forming my equation first. 2 of the angles plus the remaining, that's 58 degrees, must give me 360 because they are exterior angles. Okay, let me bring that over. And minus 2. I divide by 58 on both sides. So n equals to 6. Cool, it's a hexagon. May not be regular, but it is a hexagon. Let's finish up. So sum of interior angles. Use formula. 6 minus 2 times 180 degrees. 720. Okay, same So now let's go on. This one favorite I always see it during the exam. So 2 of them are given. How many left? How many left? N minus 2 of them are left. Okay? You can choose to use interior or exterior. It doesn't really matter. But it's kind of just easier to use exterior. Okay? Let me shift this to the side first. Because exterior is 360, it's a very nice number. There's no n inside. So I'm going to go for exterior angle first. Okay, I'm going to go for the exterior angle. Exterior angle are just adjacent angles. So 1. This one is 106. The second one. Oh, some big, some small. 44. The remaining ones. Okay, all these are angles on straight line. Okay, come, let's put everything together. I have 1 exterior angle, 2 exterior angles. The remaining n minus 2 are 70 degrees each. They will give me 360 because I use exterior angle. So 360. Okay. Let me get my answer. Obviously, my n must be an integer. If my n is not an integer, then you know something is wrong. Then you have to go and check your work. Beautiful. N minus 2 is 3. So n, oh dear. Gosh. I'm sorry. I know I was at n minus, yep, n minus 2 is 3, so n equals to a 5. We have a pentagon. Okay, we have a pentagon. Go on. Okay, this one has quite a number. Let's do them one by one. PBC, this one. Is it regular? Yes, it's regular. Regular. Everything is regular, everything is regular. Okay, one is a square. Cool. Let's do this first. PAC, now that's the interior angle of a pentagon. So I can find that. PBC, pentagon, don't write n, write 5. 5 minus 2, 180, divided by 5. Okay, see which one you prefer to use. No right, no wrong. Yeah, I haven't divided, so sorry. Divide by 5. 108. BCD. Now this one is actually a one interior angle plus a 90 degrees. Okay, BCD is one interior angle plus a 90 degrees from the square. It's not difficult, you just need to try it. BDC. BDC is down here, you have to draw it a little bit. BDC is down here. Remember, all the lengths are equal because they're all regular. So I do kind of have an isosceles triangle down here. So before I can go to the isosceles triangle, I'm going to have to find this angle first. Okay, the angle C. So let me put everything together. Angle BCD. Oh, they asked me for BCD. What am I doing? Wrong. Let me draw properly. They asked me for BCD. Okay. So sorry. So BCD equals to 360 minus those two angles. 162 degrees. Done again. Okay, so 162 happens to form the interior angle of whatever polygon it is. So let's do my working. Part 5. It's an interior angle. So I'm going to just use interior angle. I don't know how many sides. Then don't use already lah. I use exterior angle. When I don't know the number, when I have a lot of ends, right, I usually use exterior angle. Okay, one exterior angle is 18. So, number of sides, which is n, will be 360 divided by 18. It's a 20 gone, I think. I don't know why I keep pressing the wrong button. It's a 20 gone. Okay, we have covered quite a bit today. You probably want to try them a little first, okay, before we continue. So take your workbooks and you can start to try them. Okay, next lesson we will continue. And here, try your workbook. I do believe it's 8C from your workbook. I should be back on Friday. I will continue from there. Make sure you hit practice now 17. Okay? Okay, take care. Bye.